Here we have a mid-1950s Heathkit VTVM. It's a model V7A. And one of the main problems with these was that this here is, rather than having these type of banana jack plugs that most meters to this day have, this has, it's like a audio jack, and the probe had a 1 mega ohm impedance in series with the probes. Why they designed it like that, I don't know, but it's a nuisance when you buy these. You buy the meter and you want to restore it or you want to use it, you need to make one. So I found a way around that. I made a little plug here, which I was able to put a 1,000,000 ohm resistor inside it. That plugs in like that, and then you can plug regular banana jacks into that. I thought it would be interesting to get a kit that you can make your own probe, though. I thought it would be maybe a bit easier to use. With what I made here, you can put any type of probe into it. But it's nice to have both. So anyway, online I bought this kit here. It says it's for the later Heathkit meters, like the IM 11, 13, 18, 28, 54, 18 and others. So that particular design, the Heathkit used this particular setup with the 1 mega ohm resistor in it, right up until probably the last one. I think the last one of this type of meter came out in the early 80s or late 70s, because I remember when I was taking electronics in tech school, one of the guys was he got a Heathkit, and that was around 1980. So this was still this in one form or another was still around in the 80s. So this particular one, it's a V7A. The V7, I believe, was made in 1955, 56, and this is probably anywhere from up to 1961. It's a vacuum tube voltmeter. It has a selenium rectifier in it. It has 2 vacuum tubes, an amplifier tube, and a rectifier, a twin triode. So it's a very conventional vacuum tube voltmeter. And so I'm going to build this, and let's see how it works. In this, they've given you some heat shrink tubing, a negative terminal, 3 wires, a phono jack, a 1 mega ohm resistor, some sleeving. I guess that's to hold them all together, and 2 probes, and some Velcro to hold it all together. No instructions, so that would be quite confusing to someone who is just starting out doing this. Matter of fact, it's quite confusing to someone who has been in electronics for many years. Anyway, I can see very quickly that this is not exactly the same as the units that it says that this is designed for, IM 11, 13. Those are later units, as I said. And the only thing, I will not be able to use this. This was designed to be used as a all-encompassing AC probe and AC ohm. DC probe, here we have the decals that say DC probe, and AC ohms probe. Here, you can see that here. So those are to be put on the side of these. what I'm going to have to do is I'll just be able to use the DC, use this as a DC probe. These two as a DC probe with a ground, which is fine. The problem with this is those later meters didn't have this. This was all encompassing. So your AC, this one has a separate AC ohms probe, which is fine for me because I just use regular meter probes. So for this is just going to be used for the DC probe, which is fine. I don't care. But it would be nice if there were some directions with it. Anyway, I could put this together no problem. Some things here that would be nice to know, what are these sleeves for? And where do they go on? And I'm just going to have to just use common sense and put this together. So this thick wire here is undoubtedly to go here to go right here. That's the main ground wire. Although, yeah, that makes sense that this would go here. That'll be the ground, and then the other wire would go to the positive. So I'm just going to wire in these two wires. The other one I'll use for something else. So here, let's take off a bit of wire. My trusty old Sears wire strippers, there we are. And twist that like that. And just make sure that I'll be able to slip that on again. Yeah, that looks like it'll all go there. So this is twisted, and I'll just try and stick it through there. Doesn't want to go through. So I've got this slipped through the hole, and what I'm going to do is I'm just going to squeeze these down like this, and then that one like that. Just gently make it kind of a holding it in place. Now I'm just going to solder this here so that it stays in like that. So I went around and I put a bit extra on the side there. Just leave it and let it harden. Okay. Is there any excess? No, it looks pretty clean. So I'll take the second wire and remove it's got two. Let's see what the other one is here. Is that the same kind? This is a little coax. That was unexpected. And Doesn't make much sense to, I guess that needs to be soldered to the, like that. But then this little sleeve won't fit over, so what I'm going to do is I'm just going to treat this as a single conductor. I just twisted the two wires together in the little coax because you don't need shielding here. It's kind of overkill. Here it's kind of dirty looking. This melts at a low temperature, so it kind of made an ugly, it melted okay, but it kind of made an ugly looking connection there. Anyway, it doesn't matter. So in a situation like this, directions would be useful, but you have to use your wits. There are no directions. So I think this piece of sleeving fits over here, but this piece of heat shrink tubing probably goes over here, and then the sleeve goes over there. The outer one is too big for the heat shrink tubing to fit over, so it'll have to be the other one. So here I'm putting the piece of heat shrink tubing like that, and because my heat gun is in another room and it's hard to film, whoops, I'll just use a soldering iron to shrink it. You just touch it gently. And it doesn't burn. You just don't touch it for too long. It's fairly tight now. I prefer using a heat gun, but that's okay. Here is a little clear sleeve, and that I would assume just slips up over there to hold everything in place. And then you got this here, which you just slip over and it screws in. And this is a strain relief, I guess. Pull them both through. Push that one through more. And that slips over like that. And that tightens like that. And then that will plug in to the VTVM. Oh, my, wonder why the spring came out there. Well, we'll have to put that on again. I put the spring on again, and now I'm going to put on the part that fits over it. That doesn't want to go through that thing. Okay, there we are. Pull that through again and slip that over the sleeve for the strain relief. There we are. That looks pretty good. I made a mistake here. I'll have to put the third wire through because it can be used to clip onto, it's a ground, it can be used to clip onto a ground on a chassis or something, so it'll give me the choice of using the black probe for negative or use a clamp. So having that option is solved. What what I'll do is I'll just solder this onto here, and then I'll take this third piece of heat shrink tubing and put that over all three of them, and then I'll hopefully be able to get that sleeve over all three of them. Since I made a mistake, I have to open this up here. Some people might say that I shouldn't use this thick wire as the ground, but I've already soldered it on. It's just too much trouble to take this one off. I'm just gonna leave it as it is. Some people might say that this has a higher voltage, and maybe it does, but the insulation here, I don't think it's going to make a whole lot of difference touching it on. Anyway, I'm going to solder this third wire down here and then squeeze this all together. So here I'm going to put some more heat shrink tubing on this assembly here. Instructions would have saved some grief there with knowing which one to put on, knowing which lead to hook on. But anyway, it'll work fine. It's the way I'm doing it. Boy, this heat shrink tubing stinks. I'll have to clean off the soldering iron with some steel wool afterwards. Okay, so I think that should be okay. I think that sleeve should fit over there now. Okay, see the small sleeve? That big sleeve, I don't know where it slips over. Probably over the whole assembly once it's put together. And the big one's the one that least wants to slip through. There. Now, see if this slips over the heat shrink tubing. No, it doesn't go over very well. So this positive one here, I've taken both the inside and outside parts of the coax. The inside diameter one and the outside sleeve, and I've got a resistor here which is 1 meg, and I'm going to put that inside the red probe. I'll solder that, and actually these are quite flimsy, so that's one of the weak points of this type of thing, where you have to put a resistor inside the probe. These are a stupid design because you can slip the resistor inside and then it comes out here and you just squeeze this, you just screw this on. But the problem is, with the constant pulling on this, you should be able to slip some heat shrink tubing over it, but if you do, it won't fit in there. So once you've slipped the resistor one end through here, just go around like this, twist it around, and take the little screw-on ring, slip it over. And one end is meant to go on. Then you just screw that down like that, and it's good. But it's always pulling on here. It's always pulling on the resistor. So I don't think that's a very poor design as far as I'm concerned. So now the other one, I'm taking off cutting away all this stuff here, this outer braid. This, in my opinion, was not a wise choice to use coax for this purpose. Maybe they thought it would be give you shielding if you attached it all to ground. I guess that will give you some shielding, but you're not making really critical small measurements with these. So just remove that and slip this one through. Just hopefully it will go through. Push that in there. And did some come out? No. That's why it was a dumb choice. It's a braided wire inside. So I've really braided this wire and stripped the coax shielding back, and now hopefully it will slip in. I'm not expecting too much. And all this braided wire is very weak too. Whoever made the decision, is it a cost decision or what? It's a terrible decision to put that type of wire in it. Boy. Finally got it through, and I'll slip that through there. So now it's finished. Now we'll just try it out on something. So now I'm just going to test this out on a 9-volt battery, make sure it's working. So here, measuring 9, and I'll use the black probe, and that's going up to 9 too. So I was quite disappointed with this probe kit, this probe set. They used the idea of using this tiny coaxial cable. I don't think was right. It just added to the frustration of making it, and giving you all these pieces of sleeving and not telling you where they go is no directions. Quite disappointing. But that's what you, as an electronics hobbyist, you have to learn how to be creative and figure these things out. If you rely on directions, some companies like Heathkit had excellent directions, but most, especially the stuff coming from China, this I think is American, but a lot of stuff from China doesn't have any directions, and it's a nightmare, especially when it's something that you have to set up with software. Anyway, we tried this out, and I wouldn't buy one again. But what do you expect for, I think the price was okay. Anyway, we've got another probe here to use in this meter.